So we are looking at domain and range today. Go ahead and put your name on here. Domain and range has to do with us looking at graphs and looking at all of the possible x values on a graph and all of the possible y values on a graph. So domain, we look at the graph, we see all of the possible x values. X is our horizontal axis, it's from left to right. So we're looking at all of the possible values from left to right. Okay, range are our y values. Our y-axis is vertical. We are looking at all of the possible values from bottom to top. So left to right, bottom to top. Okay, one of the ways that I remember which is which, domain is really close to the word dominoes. If you were to knock down a pile of dominoes, which way do they fall? Like if you just had like dominoes sitting up, they fall side to side, right? So dominoes, I think side to side, okay? A range, I think mountain ranges. When you climb a mountain, which way are you going? Up, okay? So you go from bottom to top of a mountain range when you climb a mountain. Then you ask yourself, why am I voluntarily climbing a mountain? But I guess some people are into that kind of stuff. Okay, so to find domain and range, we are going to, for domain, list the leftmost x value, and then we list the rightmost x value. So we literally look at the graph on our coordinate plane, and we say what's the furthest to the left, the furthest to the right. For range, we do the exact same thing, but we use the bottom to the top. So the bottom y value to the top y value. Okay, here's the thing about graphs though. Sometimes, actually a lot of times, graphs continue for forever and ever in one or both directions. And so at the end of the graph, instead of it stopping, you have an arrow. So if a graph continues forever, it will have an arrow at some place, and we will write an infinity symbol. Okay, if it is the left side of our graph or the bottom of our graph where the arrow is, we are going to use negative infinity, because that would be going in the negative direction, so past where our graph goes would be a negative number. If it's to the right or the top, we will use positive infinity, because we'd be going forever towards, we'd be getting bigger and bigger and bigger. Okay, when we do our domain and range for all of these problems, we are going to write them in two different notations. So notation just means like how you notate something, how you write it. The reason why we're writing it two different ways is because you are going to see it two different ways in the future. If I were to only teach you one or the other, then there's a 50% chance you're going to see it the other way. So we're going to teach you both. We're going to show you how it's the same thing, just written two different ways. It's like if I were to write your first name and then your last name, or I were to write your last name and then comma your first name. It means the same thing on my roster, regardless of how I write it out, okay? So inequality notation uses inequality symbols. We will use less than or equal to symbols when a value is included, meaning it's a point on your graph that you can see. We just use a less than symbol when a value is excluded, which means it's not a point on your graph you can see. For today, the only time that that is going to matter is for infinities. So you will use a less than symbol for infinities. All right, the other notation we're going to use is called interval notation. Interval notation uses parentheses and brackets. We use brackets when a value is included. And we will use parentheses when a value is excluded. Okay, and then there's one more thing here. We're going to come back to this at the end. We'll do this for every example at the end. It's this just like, is it a function? I'll explain that at the very end. Any questions right now about inequality? Actually, I don't even know what questions you would have because you haven't even seen how it works yet. Anybody need anything right now? Okay, we're going to go look at our examples. Pay attention to the words I'm saying in addition to what I'm writing down, okay? And like look and see what's happening. This is our graph. On this one, this graph is just this circle. So the coordinate plane is behind it, but this circle is the graph we are looking at. Domain is left to right. So we are looking to find the furthest left this graph goes and the furthest right this graph goes. So the furthest left this graph goes is right here. The furthest right this graph goes is right here. So that means I go from -5 to 1. That is my domain. But there's a special way we write it, so pay attention to how we write it. We write that -5 is less than or equal to x is less than or equal to 1. So, domain tells us all of our possible x values. This inequality means all of my x values are in between -5 and 1. So that is how we write that. -5 is less than or equal to x is less than or equal to 1. That is our inequality notation of that. Does anyone have any questions about where I got the -5 and the 1 from? Okay. For interval notation, we use those same two numbers because the answer is the same thing, we're just writing it in a different way. So we're going to put -5, and then instead of putting the inequality symbols and the x, we just put a comma and a 1. So this means we go from -5 to 1, and then since we reach those values, we touch those values, we use brackets because those are included. So anytime you use less than or equal to, you use brackets. Hey, for range, we are doing the exact same thing, but instead of going from left to right, we go bottom to top, and we're dealing with y's. So the lowest my graph goes is here. What is the lowest thing on my graph? -1. So if I look at the lowest y value, it's -1. So I'm going to put -1 is less than or equal to y. Now I'm looking at my y values, is less than or equal to How high does my graph go? 5. So negative 1 is less than or equal to y is less than or equal to 5. Okay, and then for interval notation, we use those same numbers with just a comma in between them. So negative 1, comma 5, and that gets brackets. All right, any questions about that first example? All right, and the next one involves arrows. So moving down, domain, we are looking from left to right. What is the furthest left this little sideways V goes? 1. So my x value, the furthest left it goes is 1. So I'm going to put 1 is less than or equal to x. What is the furthest right this graph goes? So it's at 5, but what is at 5? The arrows. So arrows, I'm just going to circle these. Arrows mean we keep going forever. So if this grid was bigger, it would keep going. If it was even bigger, it would keep going, okay? So that means it doesn't stop to the right. So instead of putting another number, we're going to put less than, because we never quite can reach infinity. Infinity is a concept, not a number. Positive infinity. So that means our graph starts at 1 for our x's, and then can be anything above that. Hey, then for interval notation, we use those same two things, so 1 and infinity. So 1 comma infinity. This is kind of tricky. You use a bracket with the 1 because we can be equal to 1. We go all the way to 1. You use a parentheses with the infinity because you can never quite reach infinity, so you can't be equal to infinity. Hey, range for this one. What is the lowest this graph goes? Yeah? Yeah. Well, negative infinity, because there's an arrow. So the lowest thing on this graph is an arrow. What's the highest thing on this graph? On arrow, so positive infinity. So our range is negative infinity is less than y is less than positive infinity. Okay, for interval notation, we put negative infinity, comma positive infinity. And then with infinities, you always use parentheses because you never quite reach it. All right, any questions right now? Okay, last one on the notes, and then we need to talk about the is it a function stuff. Okay, domain is left. What is the furthest left thing on my graph? On arrow, so negative infinity. What is the furthest right thing on my graph? An arrow, so positive infinity. So if you're looking and the furthest thing to the left, it ends with an arrow. Furthest thing to the right, it ends with an arrow. Even though this arrow is pointing up, we don't care whether it's pointing up or down. We care that it's on the left side for left to right, okay? So that means our domain here is negative infinity to positive infinity. So in inequality notation, that's negative infinity is less than x is less than positive infinity. In interval notation, same thing with parentheses. Negative infinity to positive infinity. Okay. Then, for range, what's the lowest thing on my graph? An arrow. What's the highest thing on my graph? An arrow. So if it's arrow to arrow, it's negative infinity to positive infinity. So my range is negative infinity is less than y is less than positive infinity. For my interval notation, I use that same negative infinity and positive infinity, and I just put it in parentheses. Oh, Grace, Roman, and Piggy are at band. Aniga, why did you not go? Are you in band? Well, they're probably already gone, right? Okay. Hey, any questions? Hey, we are going to go ahead and talk about this is it a function stuff, and then we're going to do a Bookit to start getting some practice, because for these, you just need to see 1,000 of them. Okay, so flip this back over. This is it a function is just one little thing that we will do throughout the entire unit, basically. So is it a function is us asking if this is a one-to-one relationship. So if it's a relationship in which each x value only has one y value. From a table, it looks a little bit different. From an equation or from a graph, it is easy to use or easy to find using something called the vertical line test. So how you use the vertical line test is you see if a vertical line crosses the graph more than once, and if it does cross more than once, it is not a function. So if a vertical line crosses the graph more than once, it is not a function. Okay, so flipping this over, I'm going to get a different color just so you guys can see the lines I'm drawing. If I draw a vertical line through this graph, how many times does it cross it? Twice. Right there and right there. That means that this is not a function. So it is a no. The reason why it's not a function is if I were to ask you, hey, when x equals -2, what does y equals? You could tell me 5. You could tell me -1. There's 2 possible answers. That's not functioning. If I were to press a button on a vending machine, I should know what I'm going to get out. So if I plug in a number, I should know what I'm going to get out. This has 2 possible options. It's not functioning. Okay, if I draw a vertical line through this graph, how many times does it cross? 2. So this one, also not a function. And then the very last one here, if I draw a vertical line through it, how many times will that vertical line cross? Just one. So if I draw a vertical line here, it only crosses once. If I draw a vertical line here, it only crosses once. So you got to make sure anywhere you draw a vertical line, it would only cross once. So this one, anywhere I do that, it only crosses once. So this one is a function. Hey, any questions right now? Okay, we glue our notes into our notebook. When you glue your notes into your notebook, everyone pay attention right now. just as a refresher of the direction to put your notes so that they are right side up instead of upside down. What I always do is I take my notes and I put them so that my name and the section number is at the top. It is centered right here. Okay? So set it down on your paper where it needs to be. Then fold it down wherever the fold down is. Hold on just one second, okay? Then glue your notes in, or put glue on your notes, and then fold it back up. But if you do it that way, then it's not hanging out the side of your notebook at all, okay? We glue notes front, back, just to make sure we have enough pages in our notebooks. I like to leave the back of my quick write page blank in case I write big on my quick writes, but you don't have to. It's up to you. Okay, I'm going to stop this video. If it'll let me.